Let's examine the first DSTE bandwidth constraint model known as the Russian doll model, or RDM. RDM is the default BC model once you've enabled IETF DSTE on a router, which means it does not show up in the configuration. Next, let's configure pools on our interfaces. The nice thing about DSTE is that it recycles the RSVP bandwidth command you already learned in a previous course. The difference is that we specify different bandwidth numbers for different bandwidth constraint types. In RDM, BC0 is like the biggest Russian doll and thus must be larger than the other values. BC1 represents a subset of the BC0 bandwidth, and in this network, I am allocating 750 megabits per second for BC0 and 100 megabits per second for BC1. Let's see how DSTE signals this information throughout the topology. We'll focus on the link between CSR8 and XRV13, which is the same one we just reviewed. Digging deeper into the topology, we see a table with 8 TE classes. This is effectively the combination of a class type and a tunnel priority. You can see the available bandwidth corresponds with our BC0 and BC1 values configured under the interface. Above the table, you can see the same values reflected in summary form, indicating the global and subpool bandwidths. The terms global and subpool are legacy terms from the pre-standard DSTE developed by Cisco. You might hear them used interchangeably with BC0 and BC1, respectively. For our purposes, you can correspond TE class 0 with BC0 and TE class 1 with BC1, both using priority 7. If that's a lot to remember, you can ask the router about its TE class mappings using this command. Because this feature is rather niche, we won't customize these defaults, but it's useful to see the configured TE class mappings on the device. For brevity, we won't walk through the XR configuration, but here's a snippet. You'll see that it's almost identical to what we just reviewed on XE, and it behaves similarly. The key difference is that bandwidth allocations are configured under the RSVP stanza, not under MPLS traffic engineering, so keep that in mind. To test this, let's enhance our CBTS member tunnels by allowing them to request bandwidth. Using a regular expression, let's display tunnels 8121 and 8122 at once. I've added the priority command using a setup and hold priority of 7 in both cases. Remember, our only options are 7 and 0 right now, given the limited number of TE classes, and we'll stick with 7 for simplicity. Additionally, each tunnel makes a bandwidth reservation. The higher level bandwidth constraints typically represent more exclusive types of bandwidth. As such, we'll use class type 1 to represent our voice traffic, requesting 7 megs. We'll use class type 0 for our data traffic, requesting 35 megs. Let's quickly check the RSVP reservations known to CSR8 that target XRV12 as a destination. There are 2 entries here, each with different tunnel IDs, which correspond to our CBTS member tunnels. Both tunnels have a bandwidth reservation. The voice tunnel has requested 7 megs of guaranteed rate, while the data tunnel has requested 35 megs of controlled load. RSVP repurposes these traditional QoS terms in the context of DSTE. Next, let's query some intermediate routers to see how they reserve bandwidth. Because this is an advanced course, we'll do it from CSR8 by querying the TE topology. First, let's ask CSR6 about its link to CSR9, which is in the blue topology and should be servicing our data CBTS member tunnel. Remember that this is a broadcast connection, so the topological link is technically to the DIS pseudonode generated by CSR9, but that's a minor point. There are 35 megs allocated from TE class 0, which means there are 715 megs remaining. Note that this allocation has no impact on TE class 1. Said another way, lower level classes do not consume bandwidth from higher level classes. Let's try the voice tunnel next, which traverses CSR4. We'll check the TE topology on CSR4's link towards XRV12. This tunnel requested 7 megs of BC1 bandwidth, and notice how the router consumes it. This is deducted from both TE class 1 and everything below it, resulting in 93 megs remaining for BC1 and 743 megs remaining for BC0. In this way, RDM protects higher level classes from starvation, while at the same time optimizing bandwidth sharing and consumption. For this reason, it is the most commonly deployed version of DSTE and is the default on most platforms.